Bismillahirrahmanirrahim. Sallallahu alayhi wa alihi wa sallam. Allahumma rabbi zidni ilma. Hadith Pak. Every act of kindness is charity. This hadith is from Sahih Bukhari Shareef and hadith number is 6021. Amin alhamdulillahi rabbil alameen. Sallallahu alayhi wa alihi wa sallam. Confidence interval for population mean MEU. Case B. An important advice, be honest. In case B, the population is non-normal, sample size is large, n is greater or equal to 30, and population variance is known. Since sample size is large and population is non-normal, therefore, according to CLT, central limit theorem, x bar is approximately normal with mean mu and variance sigma square upon ns. As we have x bar, now we can write confidence interval for mu. With the help of x bar, this is the confidence interval for mu. X bar plus minus z and square root of this. You can also write this as x bar plus minus z sigma over under root ns. Both expressions or both formulae are fine and correct. And the width of confidence interval is 2 times z sigma over ns. If you will multiply this factor by 2, you will get the width. This is the example question of case B. This question is from specimen 20, paper 6, question 1. Leaves from a certain type of tree have lengths that are distributed. See, name of distribution is unknown. It is not mentioned that the distribution is normal. So this means unknown population. Population is always denoted by capital X and distribution of sample mean is always denoted by x bar. With standard deviation 3.2, see, standard deviation is given. You have to count all three things. Name of the population, unknown, number 1. Number 2, standard deviation is given. And number 3, sample size is large. This is case B. So according to CLT, central limit theorem, x bar is approximately normal. When population is unknown and sample size is large, then we always use CLT. With mean mu and variance is 3.2 square over 250. A random sample of 250 of these leaves is taken and the mean length means x bar, this is the sample mean, is found to be 12.5. So x bar is 12.5. Now we have to construct 99% confidence interval. 99% means this area. This is 0.5%. This is also 0.5%. So this total area, this one, the lower tail area, is 99.5%. 0.995. I think 2.576 is the value. You can find this value either from table or calculator. Now this is the formula of confidence interval for mu for case B. x bar plus minus z 3.2 square. Okay, let me write the formula first. Sigma square over ns. Now x bar is 12.5 plus minus z is 2.576, 3.2 square over 250. Write confidence interval up to 3 significant figures. The answer is 12.0 and 13.0. This is the confidence interval for mu. Second part of this question, write down the probability that the whole of a 99% confidence interval will lie below the population mean. Before solving this part, first understand the meaning of this confidence interval on the normal distribution sketch. This area is 99% and 13.0 is the upper limit of the confidence interval and 12.0 is the lower limit. And these values means mu lies in between these two values inclusive. I mean, the greatest value of mu is this, the least value of mu is this, and the estimated value of mu would be the average, 12.5. If the question is estimate mu, then always write mu cap is the average of confidence interval. Now, this question, write down the probability that the whole of a 99% confidence interval will lie below, this is very important, below the mu. Less than mu. See, this area is below the mu. This is the least value of mu, 12.0. So, below the mu means this area. Above the mu means this area. Below the mu, this means above the mu. And the question is, we need probability which lie below mu. So this probability is required. This one. And this is very simple. You all know 99% means 0.5% here, 0.5% here. So this area is 0.5%. And you can write this as 0.005. This is the probability, 0.005. What if the question was above the mu? Then this area would be required, 0.5%. Here is the fair solution of this question. The population is non-normal, sigma square known, sample size large, use CLT. We always use CLT when NS is large and population is non-normal. This is the condition for CLT. This is 12.0 and 13.0 and this area was required below the mu. Good luck and Allah Hafiz.